Welcome back, everyone. Today we're going to be talking about ratios, rates, and proportions. So um, let's just start with some definitions. Ratios compare values, and they can be used to determine how many times one value is contained in another value. Another way to think about that is like, say you have a bowl of fruit, and in that bowl of fruit you have six apples and two bananas. Excuse me. If you want to find the ratio of bananas to apples, that would be 2 to 6 or 2/6. You have two apples, or I'm sorry, you have two bananas and six apples. If you can treat that like a fraction to reduce it, that'd be the same as saying there is one banana to three apples, which is also true. There's one banana for every three apples. It's just a way to, ratios are just ways to compare two different numbers or two different values of things. Um, like if you also wanted to say like, what's the value of my savings account versus my checking account. So your savings account has $100, your checking account has $50. You could say your checking to saving amount ratio would be 50 to 100, or 1 to 2, which means for every dollar that you have in your savings, or I'm sorry, for every dollar you have in your checking account, you have $2 in your savings account. It's just a way to compare two different values. That's what ratios are. And they can be written like fractions as well. Now from there, you can get rates. Rates are just fixed ratios, and they represent special fixed ratios between two values. Common thing you could think of a rate is like how much you pay for something that remains consistent for the product. Um, or like, if you've ever been asked before what the better value is, where you think, oh, I'm paying like $3 for 12 ounces of juice. If you're paying $3 for 12 ounces of juice, that would be that'd be 25 cents per ounce. Or I'm sorry, yeah, 25 cents per ounce if you were to figure out that way. And then you could use that rate of 25 cents per ounce to figure out what the better deal is if they're offering, say, like 16 ounces of juice for like 350. You could use that if you can solve that too and compare the two rates, like the amount per ounce, the fixed ratio, to see what the better deal would be. Um, just as an example. Proportions from there are just statements that two ratios are equal. And we'll see that as we go down. If you ever compare like, sides of a shape of shapes that are the same, but one's larger, one's smaller, you can compare the sides as ratios, and we'll see that as we go along. Okay, so the first one, or the first problem, is going to deal with rates, because we have to find the rate, the per pound, I guess you could say, or you could have to find how much money you're going to spend per pound of meat, so that we can make a comparison for a larger amount using the same assuming that it's at the same rate. So if 3.9 pounds of deli meat costs $30.42, how much will 5.6 pounds cost? Well, we want to find the rate in terms of dollars per pound, because when we have that, if we multiply the pounds here, we're going to be left with just the cost. So we want to find the rate in dollars per pound. Okay, so when we do that, we have to evaluate what we have. We have the costs initially of 30.42 for 3.9 pounds. So we do 30.42 divided by 3.9 pounds. Now we've gone through division for even with decimals, so I'm just going to plug this into a calculator and evaluate that real quick for the sake of time. So that would give us a rate of $7.80 per 1 pound, or per pound. So you've seen rates like this in grocery stores all the time. They give you, an amount per like 1 pound of meat. Like when you're buying, steak or chicken or whatever meat you have, they give you a rate per pound. And then what you do to find the total, or what they would do to find the total, is they take that rate that they found in dollars and multiply it or in dollars per pound, and multiply it to the number of pounds that that particular object costs, and that particular object weighs, I'm sorry. So in this case, we have 5.6 pounds. So we're going to multiply 5.6 pounds by our rate of $7.80 per pound. And when you're multiplying like this, you cancel units that are in the numerator, or that are across from each other, like one's in the numerator, one's in the denominator. So these pounds are going to go away. And so the only unit that's going to be left for us is the money, is how much it costs. So once again, we've done multiplication with decimals before, so I'm just going to crank this out in a calculator just to get it going. We have 7.8 times 5.6, which would give us a grand total of 43.68. So assuming that this was the same meat, same deli meat, this works because we're finding the rate for the same deli meat based on information we were given. If we know 3.9 pounds cost $30.42, we know that 1 pound of said deli meat now costs $7.80, or we pay $7.80 per pound of deli meat. So that it would stand to reason that if you're buying 5.6 pounds, you just have to multiply it, because we know the rate per pound, which would give us $43.68. So that'd be your grand total. And we used rates to figure that one out. And once again, that involves ratios too. Rates are just special ratios. They're fixed ratios, because we know now that this $7.80 per pound is fixed. So for that particular type of deli meat, that's a fixed amount. It's $7.80 per pound. So you can evaluate, however much weight of deli meat you want to buy, you can figure out how much it would cost with that rate, because it applies to all that deli meat. Okay, if the purchase of a $26 lamp required you to pay a sales tax of $1.24, how much sales tax would you pay on the purchase of a $64 lamp? Okay, so in this case, we're going to find another rate in terms of a percent. We want to find what percentage of sales tax we paid for this lamp, assuming that sales tax again remains constant, which it usually does. You pay a fixed sales tax rate for whatever area you're in. So to find that out, we're going to take the tax that we know we paid, and divide it by the total. Or divided by the price. I'm sorry, I shouldn't say total. I should say the price. Okay, so we have $124 that we paid in tax, divided by the $26 price of the lamp. This would give us if you got the decimal answer, it'd be about 0.05, just kind of rounding off, because it's a extending decimal. It doesn't stop. So I would think if it was in a place, I'd round it to about 5%. because 0.05 translates to 5%, but we'll leave it in the decimal so we can multiply it. That's 5% tax rate. Okay, so we have about a 5% tax rate. So now what we can do with that is we can take this ratio we found, because it's essentially you're saying you're paying what the tax rate is saying is you're paying 5 cents for every dollar that you spend. That is, like our 6% tax rate is 6 cents on the dollar. So that's how they'd figure that out. So we have our tax rate of 5 cents per $1, and we're going to multiply that by that $64 lamp purchase, because now the total, I guess, or the price goes away and you're going to be left with dollars anyway, but 0.5 times 64 is, or 5 cents times $64 is $3.20. So you'd spend roughly $3.20 for that tax rate that we found of about 5%. If you wanted to be a little bit more accurate, it was like 4.76% ish, but it should be pretty safe to round here because that's normally how tax rates are. So with a 5% tax rate, or 5 cent tax per dollar, we'd spend around $3.20 in tax on the purchase of a $64 lamp. Okay, so true or false? The following fraction is a rate. This is false. It's 9 feet over 5 feet. It's comparing 9 feet to 5 feet. It's not any kind of special fixed ratio, because you can compare any two heights, and this comparison of heights isn't being used to calculate anything else, or isn't being used as like a fixed rate, like we were talking about for like, this is a fixed, in the first problem we found a fixed dollar amount per pound, or a fixed number of cents on the dollar for the tax rate. We're not fixing anything here. We're literally just comparing values, like we said here. Ratios compare two values. So that's all that we're doing. And it's not a proportion either, because proportions are saying that two different ratios are equal. So this is would actually just be a ratio. It's really important when it asks you questions like that to consider the context. They're just giving you two values being compared, so it would be a ratio. It can't be a rate. It's not anything. It's not fixing anything. They're not asking you, about this. And usually rates involve too comparing a special fixed relationship between two different values, like dollars per pound, or like tax per, the tax per dollar, tax per price. And you're using that to calculate something else here by just talking about comparing two values, so it's a ratio. Okay, so now we have to find h in the figure below rounded to the nearest hundredth. Okay, so in this case here, we're going to be talking about proportions, because you can see we have two of the same triangle. They're just different sizes. So they're similar figures. They're just different sizes, but they are the same shape. So what we can do in this case is we can notice this h corresponds to the side on the smaller triangle that's marked as 3. They correspond. They're the same side of two different triangles. Or they're the same side, the same corresponding side of two different triangles that are similar. They're just different in size. And then this 5 corresponds to this 8, because it's the long side, or it's the second longest side the 3 and the h are both the shortest sides on these similar triangles. So now with that, we can make two different ratios. The first one being we have h to 3, or 3 to h, either way it works. And we can set that equal to that's not the color I use. To 8 over 5. Because it's we're saying h to 3 is the same thing as 8 to 5, and we can say that because these two triangles make the same shape. The only difference is their size. But if we were to compare these two measurements, the fractions or the ratios of these similar sides, like the h and the 3 and the 5 to the 8, what that's saying is we should get the same value, no matter which way you do it. And we can use this now that we have two fractions to solve for h, because now we just have one variable and we have all the rest of our numbers. So what we can do is we can cross multiply here, so that we have 5h is equal to 8 times 3, which is 24. And now all we have to do to solve for h is just divide by 5. And then if you do 24 divided by 5, you should get 4.8 units. It doesn't tell us what measurement this is in, so we just say 4.8 units. And you can check that and check if 4.8 over 3 is the same as 8 over 5, which it is. They're both, this is saying 1.6 equals 1.6. It's the same, they're the same ratio. So it checks out. And you can always check your proportions like that to make sure that they actually are equal once you solve. And I believe that is it for today, or that is it for this video, I should say, not for today. I hope that this helped, and you maybe can think about your everyday life a little bit differently now. You have a little bit more of inside knowledge about it, and I will talk to you all next time.